Hey friends, welcome back to Make Anything. It's Devin here. And first of all, please excuse the bare bones setup. I've just barely arrived at my new home here in Sweden, so clearly the set could use a bit of sprucing up, but that's gonna have to wait because I am way too excited to open up my first 3D printer here in Sweden. And that is, of course, the Bambu Lab X1-Carbon, as well as the automated multicolor system. It's been a long time since I've tested a new 3D printer. This X1-Carbon has been out for a while. It's already got quite a reputation. On paper, it blows any other printer I've tried out of the water. And while it's been a bit divisive, as most newcomers to the 3D printing space seem to be, I am just very excited to try it out. As popular as this 3D printer is, I've managed to avoid any reviews and unboxings and all of that up until this point. And like Sweden, I hope to approach this machine as an impartial party. Will this become my new favorite printer, my go-to, my rock? Or will it be full of frustration like many printers often are? Let's open it up, see what it takes to get it running, and start popping off some prints. All right, unboxing time. Right off the bat, trusting this plastic bag to remove the printer was a little bit scary. This X1-Carbon with the AMS system tucked inside weighs about 22 kilos or 49 pounds. Underneath the pretty aluminum and glass panels, this printer has a rugged welded steel chassis to minimize vibrations and let the thing print at blazing speeds. You'll get a few test spools to get started, but Bambu Lab also sent me a heap of additional filaments and different build plates so I can really put this thing to the test. We're immediately presented with a little quick start guide that includes step-by-step instructions on preparing the printer for our first prints. This accessory box includes the touchscreen along with some tools and accessories we'll use to complete the setup. There are quite a few sacrificial screws that kept this thing in place through shipping, and they aren't all totally obvious, but that's what the guide is for, so as long as we stick to that, it's all good. Honestly, when the instructions are nice and clear like this, the setup becomes a pretty fun and exciting process. The X1-Carbon is already mostly assembled, but it's still satisfying to see everything take shape, and you start to learn a bit about the machine along the way. The only part of assembly that gave me any trouble was connecting the touchscreen, because the start guide said that the ribbon cable can pull out around 50 millimeters, but I only managed to get about 25 millimeters out before the resistance made me scared to pull any harder. So it was a bit tricky to plug it in with my fat fingers. Eventually though, it clicked into place, and I was rewarded with a satisfying film to peel. That never gets old. With that, the printer was ready to plug in and boot up. While it's possible to run the printer entirely offline, I chose to pair the printer with the Bambu Handy app and Bambu Studio software for access to the full set of features. Next, the printer will run through its calibration process for a few minutes.
Is this thing about to explode?
And afterwards, it suggested I lubricate the Z-axis rods and update the firmware. So I went ahead and coated the rods with a little packet of grease that I got from the accessory box, and I moved the bed up and down a few times to work it into the threads. Then I continued following the guide for the first print, applying an even layer of glue stick to the cool build plate, which is designed to handle PLA prints. Now I can prep the AMS unit, which has two little desiccant holders to keep the filament dry, and I'll add the sample spool of basic PLA. The X1-Carbon didn't come with any clippers, and in this new home I don't have any tools, so I just had to twist the end of the filament until the taped bit broke off, and then I fed it into the inlet, which automatically detects and loads filament, which was pretty exciting for me since loading filament can get a bit tedious on other machines. Now I can select a first print from several pre-sliced models that come loaded on the machine. And we do have the classic benchy boat, but I thought this little scraper might come in handy, so let's go with that. From here, the printer handles everything from loading the right filament to purging and cleaning the nozzle, with the little filament poops shooting out the back of the printer. As with many newer machines, we have an automated bed leveling system, with the nozzle probing 36 points across the bed for those clean and consistent first layers. There's even this flow calibration procedure that will lay down a few lines of filament to analyze with a built-in micro LiDAR, which also helps with leveling and inspecting the first layer of each print. And that's on top of the noise and vibration compensation that's calculated during calibration. So the level of automation on this thing is pretty incredible, and of course, it's just fast. While the noise calibration probably helps, I still wouldn't call this thing quiet per se, but there is a silent mode that basically just prints at half speed. Anyways, at normal speed, this print finished in about 5 minutes, and I was able to use it right away. Maybe PLA wasn't the best material for a scraper, but the print quality is nearly flawless. Alright, time for the really fun part, which is just printing like crazy. So I loaded up the AMS with PETG, PLA carbon fiber, and gold silk PLA, and I also swapped the cold build plate for the textured PEI bed, which generally provides great adhesion for a lot of different materials. I hopped into Bambu Studio on my laptop to slice and send some prints to the X1-Carbon, and I won't go too much into the software for this video, but I will say that I generally just used the default print settings for all of these prints, so it was super straightforward. Between all the calibration, automation, and synchronization, I literally didn't even have to go into the same room as the printer from start to finish of my prints. After a print is complete, I get a notification on my phone, and then I can just go and remove the finished prints. That is such a simplified workflow compared to any other printer I've used, and in my opinion, that's the biggest advantage of the X1-Carbon. The beautiful prints are absolutely fantastic, but this machine elevates the entire printing experience, and that's something I didn't recognize before actually working with it. Does that mean it's 100% reliable? Not quite. For example, while printing this hook, the print head was randomly stopping mid-print, and that resulted in some surface defects. I'm still not sure why that happened, so let me know in the comments if you have any idea. It's especially strange because that problem never happened again, even with very similar prints. They went right back to being absolutely stunning. Swapping filaments with the AMS system is also a massive improvement over other machines I've used, with the filament ends automatically being trimmed and the filament material and quantity automatically tracked through NFC tags built into the Bambu Lab spools. The X1-Carbon even handled this polycarbonate filament effortlessly thanks to an all-metal hot end and a hardened steel nozzle, which can reach a blistering 300 degrees Celsius. A watertight polycarbonate bottle printed without tweaking any settings? I think that qualifies as incredible. Now, for many people, a big draw of the X1-Carbon Combo will be the ability to print multicolor models. So I decided to put that to the test with the same bottle I just printed, but using a matte marble PLA with red PETG text. These filaments are generally not super compatible, and this script has some really tiny details, so I really had no idea if the X1-Carbon would be able to handle it. I brought the layer height down to 0.12 millimeters to capture even more detail, and this is when I realized just how much slower multicolor printing is, with an estimated print time of over 22 hours compared to around 3 hours for the single color version. This is mostly due to purging between each of the nearly 500 filament swaps, which also leads to a lot of sacrificial filament. I reduced the size of the purge block to use a little bit less, but it still goes through a lot regardless. Anyways, for the sake of testing, I went forward with the print and everything was looking good when I went to bed, but I woke the next day to discover that 10 hours into the print, the printer's built-in spaghetti failure detection noticed some stray filament and paused the job. It turns out I'd still underestimated the amount of filament poop produced from a print like this, and that poop chute had backed up to the point where waste filament ended up on the print bed. So as usual, it was a bit of a mistake on my part, and after cleaning the chute, I was able to resume the print and still finish the job, which was pretty much the best case scenario for this situation. Despite being paused for several hours, the resulting print still came out looking as though nothing had gone wrong. Yet another incredible feat by the X1-Carbon. I mean, this print really left my jaw on the floor. That said, with the amount of waste filament produced to pull this off, I'm gonna have to be pretty selective about when I commit to a multicolor print like this. So on I went, printing like crazy day after day with a variety of filaments, and overall I was getting amazing prints. Some notable ones are these ABS brushes, which involve some pretty extreme bridging of up to 90 millimeters to create these bristles. This print did take a few attempts because I really just needed to slow down the printing to get cleaner bridges. And I'll talk more about this print and some of the other ones I'm hinting at today in my next video. This video is really just about what the X1-Carbon can do and my experience with that. Here's yet another ABS print, a snow scraper designed by Merlin699. And while I normally prioritize print quality over speed, I actually needed to get this done really quickly before driving to my Swedish class in a few hours. So it was a great opportunity to try out the ludicrous print mode, which prints at 166% normal speed. As advertised, the print completed quickly in about 2 hours, and the quality trade-off was minimal. Also impressive were these massive lids I printed using the full 256mm width of the build plate. I did have to modify the initial purge line to give myself the space to print this, and because the front of the bed is used for calibration and cutting filament, you can't actually print on the entire 256 by 256mm bed, but this is already very large and cool, and it pretty much looks like a production part. This was PLA, but I managed to do the same with PETG as well, with a few tiny blemishes, but it's still great stuff. It was the carbon fiber PETG filament that finally gave me some problems. In this time lapse, you can see little bits crumbling off of the print, and the top surface came out pretty gross using the default settings. It's quite likely that a few extra solid top layers would have corrected this, but I also suspected that the filament may have already absorbed some moisture, which can also affect print quality. Fortunately, I had just received this NT1 Filament Dryer from FixDry, so I decided to give that a shot. This dryer can hold 2 1kg spools, it's got rollers and plenty of outlets, so you can feed it directly into your printer as it's running. It can reach 70 degrees Celsius and has a shut-off timer as well. So according to the built-in sensor, it started at 54% humidity, pretty high, and after about an hour at 65 degrees, that was down to 22%. The next day, it was back up to 40%, so I decided to keep the dryer running while trying some more PETG carbon fiber prints. Switching from the AMS unit to an external spool was pretty easy. Maybe a bit awkward feeding the filament through this dryer lid, but it is great to be able to print straight from the dryer since the little desiccant bags in the AMS unit are probably not enough when dealing with more hygroscopic materials, which quickly absorb moisture from the air. With that, my next PETG CF print did come out looking very nice. It's still a tricky material. Many of the prints stuck to the bed too well, and I scraped a few holes in my smooth PEI bed, trying to remove little bits of filament. I even got a bubble from pulling a print off the cold build plate. And several PETG CF prints had these white stress marks on the bottom surface. I did manage to fix that by cranking the heat bed up to its maximum temp of 110 degrees Celsius and just letting the print bake for a minute. So that was pretty cool. But with all of that said, I don't think moisture was the main culprit here, because over the next few days, I started facing more problems with imperfect bed leveling regardless of material, and the purge lines started printing off of the bed. I was stumped for a while until my contact at Bambu Lab suggested I may have a bent nozzle. And sure enough, the thing was quite crooked. I'm not entirely sure of when that happened, but but it may have resulted from the nozzle colliding with a failed batch of tippy tree leaves or dragging along that rough PETG carbon fiber print. In any case, the solution is simply to replace the nozzle, and I guess that's a good procedure to test out as well. The entire hot end is removed by taking out 3 little plugs and 2 screws. Oh yeah, that is indeed a crooked nozzle. I'll remove the little clip that holds the heater and thermistor into place, and I must say, it took more force to pull out the very thin thermistor cables than I was necessarily comfortable with, but after some finessing, it did come out undamaged. Maybe I should have removed this fan first as well. Anyways, as an embarrassing tangent, it was only at this point that I noticed these golden packs of lubricant grease, which is what I was meant to use on the Z-axis rods, instead of the thermal grease I had mistakenly applied right at the beginning. Who knows how much that affected my prints, but I went ahead and cleaned off the rods and applied the proper grease at this point. That mistake also meant I didn't have the included thermal grease handy for this nozzle swap, so I just used some thermal paste from my PC build instead. I'm pretty sure that should do the trick. Anyways, I put everything back together in reverse order, and in a few minutes the new nozzle was installed. Maybe it's not quite as easy as unscrewing an old nozzle and screwing in a new one, but this system works fairly well, and I was quickly back to printing perfect parts, even with that pesky PETG carbon fiber filament. So there you have an abridged version of my first few weeks with the Bambu Lab X1-Carbon. And my impression is, well, I'm honestly blown away. Because to me, this is the greatest leap forward I've personally experienced in consumer 3D printing since I got into this hobby 10 years ago. It's one thing to put out amazing prints, but it's the improvements in the user experience and workflow that really put this printer over the edge for me. This has been the most hands-off experience I've had with a 3D printer, all while being extremely reliable, and yes, the print quality is amazing. I've never had such an easy time printing with so many different filaments, and while I still made some foolish mistakes, the printer usually corrected them. There were so many times where I forgot to change the slicer settings after swapping a build plate, but the printer notices and it tells me before I make that mistake. When it's time for calibration, the printer tells me. If a print happens to lose bed adhesion, the printer notices. Sometimes. Is it absolutely perfect? Of course not. There will always be room for improvement. The biggest problem I faced was obviously that crooked nozzle, and while it may have been due to a poorly planned print or a slightly dirty build plate, I feel like most existing printers would have rammed through a print instead of bending the actual nozzle. And with all the fancy sensors on this thing, I feel like the X1-Carbon could have some kind of way of noticing when that starts to happen, and maybe even preventing it. Time will tell if I keep running into that issue, but it clearly was an issue. That said, I might have noticed the bent nozzle sooner if the printer wasn't so good at compensating for it. Any other complaints I have at the moment are pretty minor. While the X1-Carbon perfectly trims filaments and cleans its own nozzle, I do still think it would be nice to include a filament clipper and some tweezers with the accessories, because there's those rare occasions where you still need to pull away a little bit of filament from the nozzle, and when you get a brand new spool, you do need to clip the end. Maybe I'm just old school, but I think those tools are still pretty handy and they're dirt cheap, so with a premium machine like this, it shouldn't be a problem to include them in the package. There are also some software tweaks that could probably be made fairly easily. For example, on the touchscreen, some of the checkboxes are really small and close together, so sometimes I had trouble selecting the right ones. And in the Bambu Studio Slicer, I sometimes have to restart the program in order for the AMS to properly sync with it and tell me the correct filaments that are loaded into the printer. Oh, and I was also just not prepared for how fast and aggressive this printer can be, which of course is generally a benefit, but with other printers, I'm used to having to reach in sometimes while it's printing to fix something here and there. And While I was setting up this printer, I noticed a bit of film that I hadn't removed from the extruder, and I reached in to take it off, and the extruder head just blasted to one corner, and I recoiled so fast that I got a little scuff on my hand. It drew some blood, which obviously wasn't a big deal, but I don't know, it could be a problem if this was in a public setting, which I think the printer is generally great for. But maybe there should be a sensor on the door or something to keep people from interfering while it's doing its thing. Between that and the thermal grease on the Z-axis rods, clearly I can be pretty foolish, but the Bambu Lab X1-Carbon is nearly foolproof. While I still think dirt cheap printers are great for accessibility to 3D printing, if this machine is anywhere in your price range, I think it's absolutely worth it because the improvements in quality of life are so great. I really think this machine is a game changer for consumer 3D printing. Finally, I cannot finish this video without praising the Bambu Lab spool. Having enough holes to just clip in your filament while it's not in use is such an overlooked feature by a lot of filament makers, but it makes a world of difference for just ease of use. And here comes Bambu Lab, literally covering the entire spool in holes so that you can clip it in place wherever the end of the filament ends up on this roll. Brilliant. This kind of attention to detail is what makes me an instant fan of Bambu Lab. Okay, I'll be doing a lot more with this machine over the coming weeks, so definitely stay tuned if you want to see more of the X1-Carbon in action. A big thanks to Bambu Lab for providing their printer so I can share my unfiltered experience with it. And if you're interested in getting a Bambu Lab printer and want to support the channel at the same time, please consider using the affiliate links in the video description so I can keep giving it my all. Thanks for watching. I hope this video was informative and entertaining, and well, I hope I'll see you in the next one. But that's it for today, so until next time, take care, and as always, stay inspired.